Hello, New York. Always wanted to say that. Hi, everyone. So let's see how many of you are awake. Who knows what I'm going to talk about in a moment? OK. Have you played with it? OK, mixed signals. Anyway, so the life-changing magic of Kotlin multi-platform serialization. Now, what is serialization? By the way, never an animation had been more suited for a slide deck. So when we talk about serialization, one problem is that we tend to conflate many different terms together. And that is a problem because it ends up that people mean different things when they talk about serialization. As an example, very often you talk about serialization, and what you mean is serialization or deserialization. And again, it's the same word. Or encoding and decoding. Now, there is a difference between these two, although normally we, in the libraries, I'm talking mostly JVM, because I'm assuming you're all Android people, more or less. Yes? No? Yes? OK. Normally, the libraries we get on Android are just one shot. So you go from whatever model you have in your domain to, say, JSON. And back and forth, right? There is no intermediate step. There is no splitting of any phase of that part. And here, in the way that Kotlin decided to tackle the problem is very different. They split these two phases. One is serialization, deserialization, and the other one is encoding and decoding. Why is that important? Because serialization as a concept means you take some data structure and you split it up into its elements. You decompose it into what it means. By doing so, you describe the schema of the data structure without actually doing anything with it. You're not persisting it. You're not encoding it in any way. And you can recursively traverse this schema until, in the end, you get a stream of primitive values that describe, let's say, all your data in a way that can be saved or transformed however you like. Encoding and decoding, on the other side, means you take this stream and you do something with it. It could be you persist it somewhere, sure. You could transform it to a byte array or something like that. You could even do other things, like hashing, for example. Someone did an extension to this where it essentially does the equivalent of hash code, but through the schema generated from serialization and deserialization. And it's very interesting to start using this approach because suddenly, just by having this split, you have so many benefits. So suddenly, there isn't just JSON as a format. You can have many more. And you can start really inspecting the shape of your data in a different way without having the cost of, say, reflection, for example, or all those introspection facilities that are available in the JVM, but not on other platforms, for example. So if you wanted to do a real multi-platform app, and suddenly you want to use reflection on native or JavaScript, you're out of luck. And here is where this comes in. So kotlinx serialization is Kotlin's answer to the problem, let's say. It is described on the GitHub repo as Kotlin cross-platform multi-format reflectional serialization, which is, it just rolls off your tongue. Or, as I prefer to call it, kshprmfs. What is it? It's official, an official library from JetBrains that provides, again, as we said, this reflectionless cross-platform format with all the nice, let's say, integrations that you would expect from the Kotlin team. The problem with serialization generally is boilerplate and or enforcing some sort of schema. You always end up having to compromise where you generally have your models, your original models, let's say, and then you want to persist them. And it ends up that the persistence matches exactly your model, although technically it shouldn't necessarily be like that. And what happens then is that every time there's a change, you tend to keep everything in sync. You tend to keep the persistent layer in sync and your own models in sync, and that is a problem. With this, you suddenly can start splitting things in a different way, and it's very nice. By the way, I say multi-platform, but you can use it for single platforms as well. You're not required to have a multi-platform project, although it's so easy nowadays that you might as well just have it. Why not? So what does it do for you? Let's start simple. You can really, really easily have the basic use case of serializing something with one annotation. And I'm going to show you later what I mean. It then allows you to have more advanced cases and customize granularly parts of the serialization, deserialization process to the point where you can have a whole custom strategy for serializing, deserializing, or encoding and decoding, and it just plays well with the whole system. So the formats that are supported out of the box are JSON, obviously, protobuf. Is everybody aware of what protobuf is? Yes? No? Yeah. If you don't know, it's a binary format that has a schema. It's very nice. You can evolve the format. It's really useful. And this takes away the pain of normally having to create this separate file with a schema and things like that. And then there is CBOR, I don't know how to pronounce it, which is another binary format. I think similar to JSON, just binary and a bit more powerful. Never used it, but can be useful. And then technically there are other secret formats that are not very well advertised. For example, HOCON and YAML. So the reason why they are not part of the normal bulk of officially supported things is that they might be too big to fit in the normal library. They might not be properly multi-platform. In this case, they're both JVM only, or they just might be a niche sort of format that not everybody will use, but still, it's nice that they keep this sort of separate repository. One word of advice about this, if you've ever played with the library before, I suggest you to do it again, because it has improved a lot since. So I tried it the first time months ago, I even want to say a year ago. It was definitely rough. Lately, I was surprised by just how well things tend to work. Sure, you have the occasional bug here and there, and it is technically experimental, so you don't have right now the certainty that the API is going to be exactly stable. That being said, they more or less ironed out the model of how things should work. They will keep on working like this. They will just add more on top, of course. And yeah, so if you can do something today with it, you will be able to do it better in the future. That's how it is right now. You can even use it technically in production if you want. You might have to stick to a certain version if you want things to always work reliably. But anyway, like, I wouldn't right now have my whole app, using this, but maybe as an experiment or something simple, you can definitely pull it off. So before anything, yes, I want to switch and show you. Oh, I cannot switch. Interesting. Like this. OK. So how does it work? Let's have the most simple case you can imagine. You have this class, right? Oh, yeah, of course. Sorry, you're right. Let's do like this. Works? Yes. OK, so simplest case ever. I don't even know if you want to see how it's set up, but like the build Gradle, it's very easy. You just literally apply the serialization plugin on top of that, for example, multi-platform plugin. And you need JCenter. Right now, it's only there. And then you pretty much just add as implementation, for each platform, the runtime for it. That's it. By the way this is structured is that you have, a very light runtime. You have a compiler plugin that when the compilation runs, or even when you're editing, they generate all the parts that now we're going to see. And then you have an IntelliJ plugin that just helps you do that kind of generation without running the whole compilation machinery. So you have like an instant response, and things just work as if the compiler had run in that sense. And now I want to show you, for example, what it does. So you have this, right? And then you want to serialize it. So what do? You normally start always like this. You add the serializable annotation, and that's it. That's already done. You don't see things because, like, as opposed to annotation processing, they don't generate things that are added on top. They literally change and inject in the bytecode a bit of magic to make it all work. I'll show you later exactly what. And that's why you don't normally see it here, which is maybe not ideal, but you can still use it. One example of the things that are added is if I now create a place, let's say droidCon. So on the instance, there's nothing new. It's all the same. But on the companion object, I now have a serializer. Serializer, we'll see, is this. It's a main entry point for serialization and deserialization. Actually, no, first I'll show you an example then. So with a serializer, what can you do? So we can start, so there's JSON, which is just an object that contains the JSON format, let's say, encoding. And then you can do stuff with it. Like, for example, you want to stringify something, and this will use the default configuration, because normally formats can have different configurations, as you might expect. In the case of JSON, it can be strict, non-strict, pretty printed, non-pretty printed, et cetera, et cetera. So we stringify. What does it need? It needs a serializer. We have that. So we can just put it here. And then it wants an instance. And we have that. So what does this produce? Too bad it doesn't. Well, it produces a string, as you can expect. And yeah. And then we can just print it and see what happens. Ta-da. And this is it. It has created, out of the blue, the thing for us. Nice. Now, what does it really do behind the scenes? Because there's a lot of magic here, and if you want to inspect, actually, wait, I even did a nicer version of this. So this is the same class, compiled, and then it generates bytecode, and then from the bytecode you can try to generate Java out of it. I took that, simplified it a tiny bit so that it's easy to understand, and I want to show you what happens there. So suppose that in our class we added a companion object, just because it's simpler to understand. Otherwise, it will add a companion for you. So we start here, and we have the usual data class stuff, nothing new. But then you start to see something different. So by default, it will add a synthetic constructor in your class, because with that, it will try to generate the class by sort of injecting all the fields, val or vars, that you have in your class. You can technically have vars that are also added. I always like having immutable data, but that's up to you. And very interesting, like the whole optional, not optional part is handled here. Because here, it will actually check if it has been seen, as in while reading somewhere, if it actually found all the fields, because that's like a bit mask. And based on that, it will decide if the field was required or not, and either crash or not, etc. So this is how it's rebuilt. And then you have this write self. And here, we start seeing a bit of how this schema description comes into play. So it's pretty much a visitor pattern. So the code that gets generated for you tries to traverse all the elements by calling all these visitor methods recursively, so that if at some point you find a class that is a composition of many values, not just a primitive value, it will try to get its serializer and then jump into that and then go on and go on. So this is what you have, and as you see, it's as simple as it can ever be. It's just one thing. The companion on the other side has only, again, the serializer exposed as a property. That's it. And then the serializer is the interesting part. So first of all, the descriptor is the thing that describes your data, your schema. And this descriptor is an interface where this serial class desc impl is the default implementation for all the automatically generated things. In here, you can see that it gets created, and then it just adds one element to it. And that's just a utility way to say, I only have one field, because every field is indexed, by the way. And then there's just a getter to get it. That's it. Then, so there's a way to get, and this is normally only found in the generated serializers, the child serializers. So if, for example, you had, well, in this case, I guess, string, all the ones that are statically known and sort of linked will be available here. This is something used by the internal machinery, but if you ever need it, by all means, you can use it. Then there is a patch method. Now, we only talked about serializing and deserializing, but technically speaking, there is a third case, which is when you already have an object, and you just want to update it with some other data, which is something that is normally so complicated we don't even think about it. It is possible to do it with this library, although the default implementation actually throws because they just don't know how to update the data, especially if this is an immutable object, then there's no way to update it, of course. If they were all vars, perhaps, I guess you could in that case. Then the serialization method, again, super simple. You can already see how we have this sort of decomposition that is recursive. So the encoder, we invoke on it the fact that we are beginning a structure, and the structure is ourselves, like this object. We get a sort of sub-encoder that is, like the nested one, let's say. And then we only have one thing, which is we call write self, which, if you remember, only calls the string field, the name. And then we end the structure. That's it, done. We have described all there is for this object. So serialization is easy, but it's generally always easy. You could write it by hand, and it would be nice. The deserialization, though, that's the harder part in a static type, framework, because like in JavaScript, it's easy. You don't have types. You just, put something in some sort of map. That's it, easy. Here, you really want to match the types with, everything, and it has to work, and it has to work in a way that does not use reflection. So it is a bit more complicated, and I'll show you how. So first of all, we cannot rely normally on the order of whatever we are going to read in the decoding, from the decoding step, let's say. So we sort of need to have on the side all the fields that we're going to need. And then every time we decode the next element, we try to understand what index it was, so what element it was. And from there, we try to read it, and then we keep it on the side. And then at the very, very end, we try to create the object. Now, there's a few constants that are really interesting. So read done is self-explanatory. The decoder is essentially telling us, I don't have any more data for this. And so that's how you know that you stop doing it. And if you're missing anything, that's the time to to crash, I guess. But then there's also read all. So normally, you always call this decode element index every time to understand what the hell you're about to read, essentially. But if you get the read all, then the decoder is essentially telling you, from here on, you can expect everything to be in order. So just start reading until the very end, and that's it. This, for example, is used in arrays. They just, at some point, just start saying, oh, just read everything you have, because they are obviously going to be in order. Or, well, it really depends on the decoder, essentially. Now, keep in mind one thing. If you ever end up writing your own serializer or deserializer, et cetera, you don't necessarily have to do all of this yourself. It depends. If you want a general purpose, serialization, deserialization utility, I guess you should in that case. But if it's something specific that maybe only works with a specific format, just for this case, you can probably take shortcuts there because they're just going to talk to each other, and that's going to be it. And also you should obviously test your serialization and deserialization code. Everybody does that, obviously. And yeah, so that's it as far as the automatic generation goes. Now, this is just, the tip of the iceberg. Now I want to start digging with you to show you exactly how everything is split up, because once you understand that, it becomes so much easier to understand what the library is doing behind the scenes. So first of all, let's look at that automatically generated serializer. What is that? So the class of that, it's kSerializer, which is a very simple interface, as you can see here. So first of all, it implements two interfaces, serialization strategy and deserialization strategy. These ones are the real serializers. I'll just show you quickly. They have a descriptor, okay? And so on one side, the serialize, you get an encoder and the instance you want to serialize of your type. And from there, you call on the encoder all the visitor methods. Easy. Deserialization strategy is very similar, has the deserialize and patch. And the patch is different because it has the old instance if you want to get data from it. And again, descriptor. Ideally, both descriptors should be the same, although you could imagine something that has two different descriptors based on whether it's reading or writing, but that's edge case. Now, yeah, so it implements these two, sure. And as you can see, it just provides, default method for patch, throw, and nothing, just has the descriptor you need to override because it's in both interfaces. That's it. Now, what is the descriptor then? The descriptor is a bit more interesting. So you have a name, which is mostly used for checking the descriptors are the same and debug purposes. You have a kind, and this is very interesting. I think, yeah, let's explore that. So again, this is one of the things that once you understand, it just makes everything else a lot easier. So normally when we think deserialization, we always think objects all the time. But there's much more that you can serialize or deserialize. So of course, you can have either top level, that's rare, but when you decompose your object, you are going to have primitive stuff. At some point, you're going to hit the bottom and have primitives, right? So of course, this is one kind. Then you don't only have objects. You can also have a list of objects. You can have a map, like key value pair of objects, right? Although this is technically also an object, like on the JVM, but think about it more like a data structure. This is the most abstract generalization of what data structures can be. Let's put it that way. And then, that's the part I prefer, there's the union kind. So an object or a structure can be an object, which means it's a single entity, single instance of whatever it is. It can be an enum, which is the same except it can have multiple, let's say, variants. It can be sealed, as in sealed hierarchy or class, where you know exactly all the direct children inheriting from it. Or it can be polymorphic, where you have some base type, and then you have a known number of inheritors that you can serialize and deserialize from. Now, why is this important? Imagine that you are writing your own serialization or deserialization code. You are going to need to understand what you're working with, because the code for handling any of these is very different. And the moment when you have a piece of code that can handle all of them, suddenly you can serialize and deserialize anything, or more like encode and decode. So with this in mind, we go back to our serial descriptor. So again, name, serial kind. From here on, it's pretty easy. You can so from the index of a field, you can get the name, sure, and vice versa. With the name, you can get the index, okay. You can get a list of annotations attached to the parent object or to every single field. And this is one of the best parts about this. You can create your own annotations with your own metadata. So, for example, if you're creating your own serialization format or whatever, you can just annotate your fields, giving information to the framework, or, well, to yourself, I guess, about how each thing is different or has extra data. And then here, you're going to grab all of it, and you're going to be able to use it. And that is so powerful and works super well. Of course, you have how many elements and stuff, and for every element, you get a descriptor, obviously. You are going to know if the whole thing is nullable or not, and if it is optional or not. One of the changes that has happened lately-ish is that now every element by default is not optional, even if you have a default value. If you want something to be optional, you need to give it a default value and annotate it. I'll just show you. So suppose that this is, nullable, for example. This is still required. You still need to pass null when deserializing. But if I make it optional, oh, what does it say now? Wait, is it, oh, they changed that now. Huh, interesting. Well, forget everything I said. It's exactly the opposite now. They keep going back and forth about this. So never mind. You don't need that. But then if you do this, well, then how? Whatever. So anyway, never mind. You're not required anymore to put the optional. Doesn't hurt, I guess, but still. Yes, so that's it. Then another thing that I, at the beginning, found, I was not satisfied with it, but then I understood why it's important, is the polymorphic serialization. Now, in many other libraries that do this, you generally have some sort of magical thing trying to, understand and deserialize everything for you, and that has been a problem in the past, especially for security reasons, because suddenly you don't have control anymore over what kind of instances get instantiated, out of the blue. You might have an object that is definitely internal and private, and then that gets created, and you didn't expect that. So here, the way it works is that you need to register every single inheritor of a polymorphic hierarchy in a module. And by doing that, you are absolutely certain that it becomes like a CL class in a way. So you know exactly, you can get only this or that, nothing more, nothing else. It is a bit, boilerplatey in a way, but I guess that's by design, because you should be explicit, essentially. And you should use CL classes whenever you can. Speaking of CL classes, one thing you would expect is that just by annotating a sealed hierarchy, you get the CL classes automatically polymorphic. That is how it should be. It is not right now, just because it hasn't been implemented yet. So right now, even if you have a sealed hierarchy, you still need to do all the polymorphic thing. But it's just temporary. It will become that you can just annotate a sealed class, and that's it. And you get all the serialization, deserialization for free. Can't wait for that. Yes. So, and again, now we started looking at the serialization and deserialization part of the equation. But then, what they do essentially is just delegate, call some methods on an encoder. Then what is an encoder at this point? We can check that out. So an encoder, first of all, is contextual. You have the option, so let's put it this way. If you can, you should have everything linked at compile time. Everything statically known, like no ambiguity whatsoever. There are cases where that is not possible or is not exactly what you want. It might be that you have some model that can be serialized in different formats. It can be that it's something that you don't know until runtime how it's going to behave. In these cases, the resolution of, let's say, the dependency graph of all the serializers is not going to be computed at compile time, or at least that part of the subgraph, but at runtime. And that is entirely based on these context modules that you can compose. So the way it works is that you just register, I'll just show you. You pretty much, no, wait, because you want the, where are you? There you go. So when you create a serial module, there's only one implementation which is internal because you create it through a special method. But what it does is just registering things. Where are you? Wait. Because I never remember the name. Oh, well, I think it's just serial module of, serializers module. There you go. And then it expects a list of serializers. So in this case, for example, we could say place.serializer. This is a module, okay? The nice part about this is that you can create these collections of modules. For example, say you are a library author. You can create your own models, etc., and then expose just one module that contains all your serializers that can be just ready to use. And if you're someone that wants to consume that module, it's as easy as, I'll show you. Yep. As adding them. This creates a sort of composite module that has all of them inside. And this way you can just add different pieces, the way you need them. And that's how you do it. Where do you use a module? When you finally get to the point where you are going to, at some point, call a method for encoding, like in the case of JSON stringify, for example, you have different methods that actually take the module. So, where are you? Yeah, so here it's just, you can install a module, but normally you just create your own instance of JSON, and that's how you do it. Where are you? Oh, come on. There you go. So when you create a configuration for your JSON, you can add the module. I'll show you how to do it very easily. You would do something like JSON dot. These are default configurations, for example, indented, plain, non-strict, unquoted, just ready to use configurations. Or you can create your own, which is, wait, there was like a build, no. Yeah. And here you have the options, right? So for example, you could say serial module, blah, 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 blah. Oh, let's say like that. Yeah. Mm-hmm. And then when you build this, no, where is it? No, sorry, you pass the builder to the JSON instance. Yeah. So this is a Lambda that expects a builder. And actually, even better, you even do this. No? Not even this. This creates an instance of the JSON configured to use your modules, and then from here on, you can, again, stringify, etc. So for example, if we had yes, because one important thing to understand is that as long as you control your own models and objects, everything is fine, sure. But what if you want to serialize something you don't own? And this is where the so-called external serialization comes into play. And it allows you to serialize something that you don't own. And for example, one way where you can pass different values is through a serial module. You normally do something like this. You create an object. My serializer is there. That extend blah, blah, blah. Let's say again for place. No, like this, right? Yeah. And then you can say serializer, wait, is there this one? Yes. Yeah, for class, and you say place. You see that the error disappeared, and that's because behind the scenes, they're actually already generating all the boilerplate, even for the external serialization. So this is really, really convenient, because suddenly the whole tedious machinery of having to go and specify all the things, boom, it's gone. And the best part is that you can customize this like piece by piece. You don't have to say either all of it or nothing. You can do something like, you can override just one piece. You could override just a serialization method, for example, or just a descriptor, etc. And you can, of course, compose this to create all sorts of customizable things. Yeah, and last part is the encoding process, as we said, which is, again, very simple. If you ever use written like a parcelable instance, that's more or less the same. You just write the primitive values one after the other. It might not be the easiest, depending on the format, to, let's say, make it talk this sort of language, this structure of just having things serially. But so far, from all the use cases that the team has collected, it seems that this seems to be a universal solution. You can fit pretty much anything into this. And if you ever have any special requirement, although it's not pretty per se, you can make it so that whenever an object expects to be deserialized or serialized, it can check the type of the encoder. For example, there are things that expect JSON. And if you're trying to put a non-JSON encoder or decoder, they will just crash, which is fair for certain use cases. And that's it. And you have also, as we said, like structure, beginning, or collection. And then once you begin a structure, you get a composite encoder, which is just like an encoder, but for structures. And it's pretty much the same, except everything is not top level. It's for a specific field index, right? And that's it. So all of this machinery is just so that you can separate, first of all, the description of an object from the actual writing somewhere, anywhere. Reuse that a lot. And then, so there are plans of things that are not yet implemented. There's a keep for this. You should definitely check out if you are interested, because it contains a lot of information, which is 95% accurate and up to date. But it's definitely valuable to read it. And among the things that they are planning to do are schema generation and validation or enforcement, which means, for example, from your own models, you could automatically generate a schema, save it, and then if you, by accident, change the schema, it will not compile, and it will ask you to have a migration, because otherwise you cannot continue. And I cannot wait for that. So I think we are definitely out of time. If you have any questions, I guess you can come to me. And yeah, so thank you very much for listening to me.